Hello everyone, my name is Prashant and today I'm going to talk about a MapReduce, which generally refers to two things, a programming model and a specific implementation of the framework. So MapReduce generally works in conjunction with your name node or the Hadoop framework to give you the desired output. So the main function or the main purpose why we have a MapReduce is to simplify the development of a large scale distributed and fault tolerant data processing application. So this is why the MapReduce framework is being developed, and mostly many of the programmers written most of the application in Java to get the work done. So it generally been break down into two parts, a map and a reduce part, which generally works on data provided by the user, and it produces the output in the form of an intermediate key and value pairs. And whatever the output we have got from the map function, it generally been feed to your reduce function, and which work on this intermediate key value pair. It process all the values together and give the output. So generally these two works in conjunction with each other to give the desired output. So this is the main function of the map and a reduce task or a map reduce. Generally map and reduce part does not take care of any of the parallelizing of the work or scheduling part of a job to the worker, monitoring or any type of recovering of failure. This is generally being handled by the Hadoop framework. So map and reduce or whatever the code which has been written by the programmer doesn't need to take care of all these things. This is generally being taken care by the Hadoop framework itself. So this is how the various stages of MapReduce function works. So first client need to submit a job, and then the developer or a programmer need to write a map specific function. Then there is an intermediary stage called a shuffle and sort. At the end, the reduce task which will be executed, which will give you the desired output, which is being fed to any of the UI application to give you the desired result. Now, how the client submitted any job. So client application can be of any type of application. It generally use the framework API to submit the job, and the job submission generally take place on the job tracker, which accept any kind of a job submission. And it is a framework which is used to decide how to split this input split or the chunk of data which is being provided by the our client. And now we have something called a map task, which has been a code written by the developer, and for each of the input split which has been received from the client side, there is one specific map task which runs the specified function which is been provided by the user on each of the record split. And generally these map tasks are executed in parallel because the chunk of a data which is being provided is not being constrained to any specific node on a cluster, which is being distributed among all over the cluster. So this is make a use of a parallel processing which will result in the speed up the data, and so that, and also provide you the fault tolerance, so that if any of the node in the cluster fail, you don't have to lose the entire process or something like that. So generally map function takes a key value pair as an input and produce 0 or more intermediate key value pair as an output. And this intermediate key value pair which is being produced is being fed to your shuffle and sort job, or ultimately at the end of the reducer job. Now the shuffle and sort part. The shuffle and sort part is generally being done by the reduce function, and it works is like to copy the intermediate data from each worker, and generally this copying of data over the intermediate worker, because the data is not being stored on a single machine on the cluster or called a data node in the cluster, it is being distributed all over the network. So because of this kind of a issue, because it has been distributed and the bandwidth is limited, or it's the bandwidth which slow down the entire process, to reduce the overall time, the framework is permitted to begin copy data from a complete map task as soon as they are finished. So as soon the map task is going to produce the output or the intermediate output, it is being taken over the network and filled and give it to the shuffle and sort job. And once this intermediate data is produced, it will give it to the reduce task, which is generally been an API which is written by the developer, and it will accept this data in the form of a key value pair, and the output is being produced, which has been split, which has been created on the HDFS as a part of a as each and every part. So means it will be specified with the help of reduce job, and each reducer produces a separate output file, usually in the your Hadoop distributed file system. So this is how the whole MapReduce function work. So just to give you the brief idea with the help of the screen that how it works. So basically, like here you have an input split, you have an input which has been provided by the user, and then you have splitting of data all over the place. Then we have a map task, then there's an intermediate place called shuffling, sort and shuffling, and finally the reduce. And then you got the final result, which has been used by any of the UI developer to produce and to give you that graphical screen or graphical output. So mainly in the MapReduce phase, we have a two important daemon called a job tracker and task tracker. So let's discuss what are those daemons. So job tracker is basically the master daemon. So whatever the data which is being fed by the user with the help of any of the code or the API provided by the Hadoop framework is being fed to the job tracker, and this is the master process which is responsible for accepting a job which has been submitted by the client. And once it got a job, depending upon the availability of the slot, it will schedule the job onto the worker node or called the data node. The other task provided by this job tracker is like it's act as an administrative point, which is used to track what is the state of the current worker node or the data node, how this task is being currently being progressed, and what is the current state of a cluster. All these function or all these works are performed by the job tracker. And there is one for the entire cluster. There is one job tracker, and like a name node is our single point of failure, the job tracker is also a single point of failure. So generally it runs on a same machine where name node is running, which is not ever necessary, but the hardware should be a high-end server where it is running. And generally your data node and the job tracker will communicate each other with the help of a RPC or a remote procedure call. To see the administrative interface of this job tracker, you need to use your name, the host name of your where job tracker is running :50030. If you need to see the progress of your jobs. Then we have something called task tracker, which generally runs on the data node, and whatever the task which has been assigned by the job tracker, the function of the task tracker is to accept that task and process the user code and execute those code locally and report the progress back to the job tracker. So there is only, like, we have a one job tracker, we have a one task tracker per worker node, because this is one of the limitation of Hadoop framework version 1, where we only have a one job tracker but we have a multiple task tracker, and it runs on the same machine as the data node. And to see the administrative interface, you need to use a hostname :5060 to save. So let's see how your job tracker and task tracker communicate with each other. Like I mentioned earlier, there is a RPC or remote procedure call, or there is a heartbeat message which is been sent between your data node and a task tracker, sent by the task tracker to the job tracker to inform its progress or the current held. This is the way through which it will tell about the current status, and in the status it will also tell what is the total number of map and reduce slots available currently on that particular data node, and what is the current task which is being currently executed on the particular task tracker. If there is no heartbeat message which is been sent from the task tracker to the job tracker, then the job tracker or the name node will think that this node is dead. So in case of any failure, because this is a kind of ideal scenario, but as we have a commodity hardware and there are so many failures which has been happening on the commodity node side, so when there is a kind of a failure happens on the task tracker side, it report to a job tracker in the next heartbeat message. Job tracker, once it receives that a failure from any of the data node, it try an additional attempt and try to reschedule the current job on the similar machine or maybe on the other machine on the cluster. Generally try the default of 4 times. So if that fails, then there is either 2 conditions, but before that it will at least try a 4 attempt to reschedule that job onto the similar or the different node in the existing cluster, depend upon the availability and depend upon the what are the slots and a task available, or what is the current status of that node in terms of CPU or any kind of a utilization. So if multiple tasks from different jobs repeatedly fail on the specific task tracker, the task tracker which where all these tasks are failing is added to something called a global blacklist for 24 hours, which prevent any task from being scheduled on the particular task tracker. So if there are different jobs uh, which has been failing, but if the same job which has been failed on the same task tracker repeatedly, then in that case is that job will be uh, put into a job level blacklist. I mean that particular data node or that particular task tracker is being added to the job level blacklist. This is like to be prevented for further corruption or to remove that data node so that the other job should or the future job should not fail on the same task tracker. So this framework which is available with Hadoop 1.0, which have a two main daemon called data node, task tracker and job tracker, have some limitation. So for example, in case of a Yahoo which is implemented a cluster of around 4000 machine, so this job tracker is kind of like a highly means resource requirement on this single job tracker is too high. So when this is kind of overloaded with a kind of overwhelming kind of response from these constant heartbeat going and all, it need to keep track of each and every job. And the second major disadvantage of this is like it's kind of a single point of failure. So rather than the single daemon which take care of everything and everything in the sense like assigning resources such as CPU and memory and handles MapReduce specific job tracking. When the starting from Hadoop version 2.0, there is something called Yarn or yet another resource negotiation which comes. So instead of single place, it split the job tracker into two parts called resource manager and application master, and task tracker in the form of a node manager. So what exactly is the resource manager? So resource manager is basically a replacement of a job tracker, and it is a separate daemon which is responsible for creating and allocating a resources to multiple applications. So now earlier like a resource allocation as well as the assigning of individual MapReduce is been done by the job tracker, but now we have a two daemon. One is resource manager which is just responsible for resource allocation, and application master which is responsible for each individual map and reduce job. So this is like this application master or this framework is different from what we have earlier, because earlier we have a kind of a centralized framework, but now in case of this application master, each job has its own job tracker equivalent called an application master. So there is no centralized framework. So in this case, if there is one job which is failed, it's not going to affect the entire other job which is running on the same cluster. And secondly, we have something called node manager, which is a replacement of a task tracker. Earlier we have a MapReduce specific functionality such as launching and managing tasks, whereas like this is a mainly a kind of task of a task tracker, that whatever the jobs it got from job tracker, it need to implement it. But now this node manager is something more generic as compared to what we have earlier in the task tracker, and any type of process dictated by it is used to dictate any type of a process. So now because of to overcome the limitation of only a specific kind of a MapReduce job, now it's possible to run even a non-MapReduce specific application with the help of this Hadoop 2.0. So like in many of the cases we heard that now even we can do graph processing, not only MapReduce stuff with the help of Hadoop framework 2.0. Thanks for watching.